Finsweet, agency, product, community. That's effing sweet.
That's effing sweet and that's effing late. I apologize, everyone. We are 5 minutes late. That's on me. I was just deep into working and I didn't realize that we did a time change, time zone change. No, like winter time change here in Spain. So my whole schedule is just messed up right now. And I apologize, but we are here. Welcome everyone to another technical Friday live stream. Today we are talking about how we use GitHub at Finsweet to collaborate and develop all the projects that we build. And I'm excited. So I'm just finishing setting up everything. You can see not even my camera is properly set up, but I think that we are good to go. So let me say hi to everyone. Thank you for being patient. I know I've been 5 minutes late. So, hey, Sylvan, thank you for coming. Hey, Yash, nice. Raul, Dimitri, nice. Fred, good morning, good people. Glad to be with you. Yes, I'm also glad to be with you, Fred. Thank you for coming. Okay, I wish that everyone had a good week. I don't know if for you guys is also a week, a holiday festivity at your countries. Today in Spain, it is. We are celebrating, how to say that, Todos Santos, like All Saints Day. I don't know how to translate this, but essentially, people here in Spain, not me, but people in Spain are not working today. Yeah, it would be Halloween, but it's something religious related, I believe. I'm not sure, but yeah, festivity here. Maybe some of you also have some free day, or maybe not. But anyways, I wish that you have a good day. Amro, thank you for coming. Nice. And Bido, Patrick, hey, hey, love it. Hey, Jill, nice. Okay, got a few people here. Okay, great. So let me just introduce what we're talking about today, and I'm gonna straight away start sharing my screen. So the idea is that we at Finsweet, we build a lot of projects, and those projects require collaboration, require code versioning, require passing reviews to make sure that we're not shipping um, anything buggy to production for people to use. And we need also some security around this code. We need to make sure that everything is secure. We're not leaking anything, or we're not, as mentioned, we're not introducing any problems into the code that we are putting in the code base. So today I'm not going. This is not going to be a class about how to use Git, although you might pick up a bunch of concepts. It's more about how we implement the what workflows we implement at Finsweet when working in GitHub. The way that we develop no code, the way that we commit that code, the way that we share that and open pull requests so another person can review them, the way that we set up workflows to lint and test everything that we are committing to the code base, and then the way that we deploy things. I will try to kind of like create these overview of the full system that we use at Finsweet. Hopefully, everyone will be able to follow along. You don't need to know Git. I believe you don't need to know coding. You just can try to understand this together. Hey, Chavi. Hey, Mike. Hey, Ivan. Nice. Thank you for coming, guys. Great. Okay, so first of all, how about we talk about what is GitHub, right? What the hell is GitHub? And actually, this might be my account. Yes, let's open it in incognito first. Because GitHub is what we use at Finsweet to build and ship software in a single collaborative platform. Look at that. This this title is already enough. But do not confuse GitHub with the concept of Git. That's two different things. Git, it's actually a concept. It's a system that is implemented by many platforms like GitHub, for example. So Git, let me try to look for the official description. Git is a distributed version control system that tracks versions of files. That's it. Okay. So with Git, essentially, instead of doing what happened 20 years ago, where you would create a file with some code and then you would want to have a different version, so you duplicate that file, maybe you would call that file my code version 2 or my code version 3 or my code version final, this one is the final one .js. So instead of doing that, Git essentially implements a version control system on our files, which means that for a single file or multiple files that we have in our code base, we can see exactly all the changes that happened to those files. We have a history of changes, and we know that this line of code was added at this point in time, or this line of code was modified, or this line of code was removed, or this file was created, this file was removed, this file was moved from here to there. Like every single change that happens in a code base, it's registered in this version control system that it's called Git. So instead of using Git locally in our in our networks, what we do is we use this third-party service that's called GitHub. You may also know other services like GitLab or what else? I always forget about names, but there are multiple systems. Okay, so in our case at Finsweet, we use GitHub. So inside GitHub, essentially we have what's called a repository for each of the projects that we build at Finsweet. Hey, Rosemary. Nice. Thank you for coming. So these repositories are essentially containers that contain the code base for a specific project. Project 1, project 2, project 3, that could be whatever. So at Finsweet, because we're an agency, but also we develop products, at Finsweet, we've got multiple things. We've got repositories that are just meant for clients. Maybe we're developing some custom code for a Webflow site. That could be. Maybe we have some things that are just internal, maybe for the Finsweet.com website, or for any tool that we are building just for internal use. That could also be. Or it could be something like a product. For example, Wist has its own repository. So every single thing, it's divided between repositories. So that could be project 1 or project 2, etc. Okay, so essentially inside these repositories, all our code lives in there. So here, all the code for project 1 existing here, all the code for project 2 existing here, etc. And one of the most known, I would say, examples that you can find, it's the developer starter template that you can find if you just, probably if you Google Finsweet developer starter, probably appears the first option in the results, maybe. And this is essentially a repository, right? In this case, this is a template. This is not specific for a project. This is a template for creating projects, but it's also managed inside a repository, which contains a bunch of files. It contains, for example, all these setting files. It contains the source folder with all the files, with the code, with these amazing Hello John Doe code, very complex, very nice. And then, as we mentioned, because Git is essentially version control, we've got a history of all the changes. So as you can see here, we can go per folder, we can go per file. Let's check how many changes has this file gotten. There was an initial commit 3 years ago already. My God. And then maybe here there were some changes, and we can keep track of all these changes. You can see how I pushed the change 2 years ago, where we did some updates to the code like that. Very simple, right? So this is essentially where we store the code. Now, what I want to present today is how we actually manage these things, because you need to have some kind of a system, some control over who's working where and who's doing what and what things they're trying to put into this code base. We need to be organized. We need to be following a system, as I mentioned, right? So let's try to I would like to present to you a kind of like a made up example, but it could be a real life example. So let's imagine that we've got a project. Okay. Let's call this project. How can we call this? We can call this. Can you guys give me an idea of a project? We can call this. Trying to think of something funny, and I'm always very bad at it. I'm just blank, man. My cool app, like that. I'm gonna be the least original of all. So we've got our cool app, and these code base here, as mentioned, contains a bunch of code, right? Let's imagine that it has a source folder with an index.ts, and maybe it has a package.json, and maybe it has blah, 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 I don't know, like that. Let's just have some two files in there. Okay, very simple. Now let's present with the case where we want to push an update. So this my cool app requires to implement a new feature, and that new feature could be something like let's actually think about of a bunch of features. Something like add an account wall, so a login and an auth wall, so people has to log in. And we can break this down into add a login page, add a sign up page, and then maybe add login, logout buttons, and then add protection to the pages. I don't know, something like that. Maybe we could also think about add a paid cool feature. It could be also something like fix a specific bug. Maybe it could be, let's try to be more specific. When users click on X, they get transferred $100. This is a pretty bad bug, right? Okay, so we've got a bunch of things here going on, and we need to keep track of these changes. Because, first of all, we need to plan about the things that we want to implement, but also then we need to take some steps to implement this thing. So how about we start by that? We start by just listing things, right? Actually, you know what? Let's create a repository. Let's do it. Let's create a repo because I think that we can do this as a real live example. So I'm gonna I might just create a new repo in my own account. Yeah, why not? Actually, let's do it on Finsweet. So let's do stream GitHub like that. I'm gonna make this public, so maybe you guys can interact with this because we're gonna build some custom feature, and I would like somebody to review this. Okay, so Finsweet, and this is gonna be stream GitHub, and this is for a cool live stream like that. And let's create this like that. Empty repo. We don't have anything at all like that. Okay. So first thing that we want to do is we actually want to list these things, and we make use of something that is built in GitHub that is called GitHub issues. Essentially, GitHub issues allow us to list things that we need to implement in the code base. That could be whatever from feature implementations. It could be bug fixes. It could be cores, like, for example, upgrading dependencies. Or it could be whatever, like cleaning up the documentation, like whatever thing, etc. There are many, many things that we could want to list for a project. So in GitHub issues, what we do is we list these things. So how about we go ahead and do this? We can create a new issue here, and we can call this create some code. This is an issue asking Alex to please create something. Otherwise, it's the code base is empty, like that, right? So let's create this, and let's create another one. Let's create another issue, and let's call this fix the awful bug. Bug X is causing Y, whatever, right? But not only we create issues to keep track of everything. You can see how now we've got 2 issues in here. But also we try to be a bit more organized, because it's not the same an issue that it's a feature implementation, an issue that it's a bug implementation, an issue that it's just for some core that you can do whatever you want, right? So let's go back to these inside these issues, and let's try to classify this a bit more. We can go ahead and give them some labels. For example, this could be a, I don't know, new feature request. I think that that would be enough. So in this case, this would be an enhancement like that. And if we go back to the other issue, this could be a bug like that, right? So now we're starting to organize a bit more everything that is happening in our project. We've got a bug here, and we've got an enhancement like that. Could be more things. We're going to do that later. But we can improve this a bit more. For example, we could be creating projects, but I think that it's a bit more complex. So let me tackle this later. We can also create milestones, and that's what we do when we try to organize our backlog of tasks. So inside GitHub, there is the concept of, again, milestones. So GitHub issues can be classified into milestones like that. And these milestones allow us to have a clear picture of what's actually more important or less important. So let's imagine that here in these milestones, we've got a launch date. And this launch date could be by today, like that. So this is for the launch, like that. And then we could have other milestones. This could be something like important bug fixes. And these could be, doesn't even need a due date in this case. It's just something that we know for sure that there are some important bug fixes that we need to do. So all these milestones, again, allow us to organize everything that we need to do in our code. So let's go back to our issues. And because we want to launch this project by today, I'm going to add this to the launch milestone like that. And then the other one, we'll just put it in the bug fixes, important bug fixes like that. So now we are starting to have some kind of organized system where we see clearly, okay, we've got these 2 milestones, and the launch that it's due by today, we're actually still are 0 complete because we need to do we need to implement some features. And right now we've got one open ticketing here, one open issue. So how about we tackle that, right? So now that we've got this cool project, we've got a clear roadmap of the things that we want to implement. Now we need to start building those things, right? So usually when you work in a code base, what you do is you write some code and then you commit that code. Commit the code. So essentially you ship that code to the code base, to the GitHub repository. So then this code, it's stored in our repository, this box that contains all the code and all the changes that happened. But instead of committing directly, instead of just grabbing the code and putting it directly into the repository, we need to first define another concept, and it's the concept of branches. And this is something that it's a specific of Git. It's not a specific of GitHub. And essentially with branches, what allow us to do is to create branches like a tree. So imagine that we've got our first version of the coding here. This is our first version. Like, let's not call it version. Let's call this the main version. The main version. And this main version, essentially what it means is that it's the production version. So let's call this production, like that. Okay. This version contains what's currently living into production, what the users are using when they go into my application and they play around with it. They're using the code that is living here in main. Now, obviously, we want to be doing some changes, but we don't want to be shipping those changes immediately to the users because we need to test those things first, right? So in that case, what we can do is we can branch out this version to create other versions. So let's imagine that in here, not only I got my main version, but also I've got my staging version. And this version, let's call it just staging. Okay, so staging like that. And I'm gonna remove this so you don't get confused. You already get the drill. Main means production. So we've got this version that it's called staging in here. And also maybe also I want to create a different version in here because I want to, I don't know, like you really don't have a reason. Anyways, let's just think about staging. So this staging version, it's based on main. So everything that main has, staging also has it. But additionally, staging has some changes. So maybe here there are X lines of code added, X lines of code removed, X lines of code updated in comparison to the main branch. So this staging branch contains some changes. And all of these changes, X lines of code added, removed, updated, whatever, or files, or etc. All of these can be summarized as what we call a commit, right? A commit is essentially when we grab a bunch of code that we've changed, we've done some things, and we send that to the code base. That's a commit. We package that and we put it in a commit, and a commit could contain a bunch of changes. It could contain adding code, removing code, updating code, whatever, right? So it has a bunch of commits, which means that staging branch will have X commits ahead of main, like that. Because in main, we have not been changing anything. Main is stable, but in staging, we have been changing things, right? Now, obviously, this means that because we have different versions, we also can deploy different versions. Because maybe this main it's living in example.com. Let's put it in here. This main it's living in example.com, but my staging branch, maybe it's living in staging.example.com. It could be whatever, but this means that we can be implementing changes while the users don't notice it, because the users are happily using example.com. They are fine. We are changing things in here where we just test out things. We break stuff, doesn't matter, because it's not affecting anybody. So we've got our main branch, we've got our staging branch, and additionally, and this is how we work at Finsweet, we've got our feature branches. So I'm going to create a bunch of branches here. Let's call these feature 1. Let's call these feature 2, like that. And the same thing, because we can be creating different versions and each version is independent, but at the same time, they have a history of changes. We can collaborate in here. It means that if multiple developers are working inside this code base, they don't need to be working in the same exact feature. Maybe somebody's working on building the authentication system. Maybe something else it's focusing on fixing a bug. Maybe something else it's focusing on just refactoring some stuff. We can be doing multiple tasks at the same time. And those tasks don't need to be living in the same version. They can happen, they can live in different versions. And I think that if I Google GitHub branches, maybe we can see something that illustrates a bit more. Yeah, like that. I think that this represents a bit more what I'm trying to explain, which is that in the history of changes, when we are branching out, we are able to do our own work. And then somebody else, it's also in a different branch, it's also able to implement that work. And the moment that we decide to merge those things, these things will go into their respective places. You will see when I talk about merging the code, when we put this together, right? So because in our project, I want to implement something, first of all, what I'm going to do is I'm going to create 2 branches. The first branch is going to be our staging branch because we always use staging first. And then the second branch, it will be my feature branch. So let's go, and I'm going to, and this is a matter, it's a preference of mine, but I'm going to use GitHub Desktop for this. You really can use Git in many ways. Can I zoom in here? How do I zoom in? 1 second. Zoom in. Yeah, I was doing that. Come on, give me more zoom. More zoom. Okay, good. So in my case, in case that you're curious, I use GitHub Desktop to manage everything related to pulling the code, creating branches, switching branches, committing the code, opening pull requests, all the stuff. I use GitHub Desktop, but this is a preference of mine. You really can use GitHub in many ways. You can just use the CLI, the command line interface, and you just write the commands yourself. You can use other tools like GitKraken or not Kraken, but Kraken, or what's the other one? There are a bunch of them. Just Git clients that allows you to do these things a bit more visually. I like visual things. So in my case, I use GitHub Desktop. So let's create a new branch here. I'm going to create you can see how we've got the main branch that contains our main source code. And then in here, I'm going to create, actually, I need to commit something first because cannot publish unborn head. Hold on a second. You know what? Da, 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 da. Do I need to do anything here? I might. Yeah, yeah, really, because I need to commit something. So let's do a README file first of all. So README MD, and this is my cool project. Yay! Zooming in before Gabe gets mad at me. Like that. Okay, cool. So so I'm going to commit this, okay? And you can see how this is already giving me the option of, hey, I created this readme.md file, so I'm going to commit this to main. So let's commit this like that, and I'm going to publish this, and now we've got our repository with the branch main that contains our main source of truth. Now I can start creating branches. So first of all, let's just create staging. So I'm going to call this staging branch like that, and I'm going to publish that branch. That's it. That's it, enough, okay? And I know that now we've got two different versions. We've got the main branch and we've got the staging branch. And we can even go ahead in GitHub and check this out. So if I refresh this, you will see how I have two branches. Sorry, main and staging. And main contains this version in here, and staging, because right now it's based on main, it contains the same exact code, the same exact file, like that. But now I could go ahead and try things. Okay, so just for testing purposes, you can see how I can switch from branches. So let's go to staging and let's just update this. This is in staging, like that. And let's commit this. I'm gonna say, yeah, update readme. It's fine, like that. Although I'll talk about commit messages in a second. So now in here, we can see how the main branch just contains my cool project. But if I switch to staging branch, it contains both my cool project and this is in staging. And we can even check that the staging branch has two commits, but the main branch has just one commit. The reason is, you already know it, there's a difference between main and staging now. Staging has one commit ahead of main, right? And now what I want to do is I want to create my feature branch, because staging is going to be only for testing stuff after validating it. So I'm going to create another branch, not rename, new branch. And this branch is going to be based on staging. And I'm going to call this, what we do at Finsweet is we follow the convention of using the issue number. Any issue that you open at GitHub, you can see how it has a number. So this one, it's issue number 1, issue number 2, etc. Everything is numeric at GitHub. So I want to create some code. So we use the issue 1 and then some description. So it's going to be create some code, whatever, like that. Okay. And now I've got my branch that it's specifically made only for the issue number 1. If somebody else is working on something else, they will create their own branches with the description that belongs to what they're building. So then when we've got a big team that everyone is working on different stuff, it's very clear who is working on what. You know that, okay, so I've got my main branch, I've got my staging branch, and also here it looks like there's some ongoing work to implement issue number 1. Then probably, let's do that. Let's go back to staging. Let's create another branch. There's going to be an issue number 2 that it's just about fixing the awful bug. So fix bug, whatever, like that. And then you can see here how this is very clear now. There is some work being done here for issue number 2. There's some work being done here for issue number 1, and etc. Nice. So let's go here and let's just do some, I don't know, like index.js, and let's do console log. Hey, this is our application. Look at that, super cool. Now let's talk about actually how we name things. This is just a matter of preference, and this is something that I tell people at Finsweet to do, but it might not be the same preference for everyone at all. You might see a lot of people talking about just using conventional commits and stuff like that. So every single commit that goes into the code base has a very clear description on the fix or featuring or breaking prefix, and then a proper description, etc. So you can see, for example, here, feed allowed provided config object to extend other configs, blah, 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 right? So many people would be like, okay, yes, I'm doing this change. So I would come in here and say fit, and then added some console log, etc. Right? But you will see how in our case, the way that we work at Finsweet, it's not that relevant, because what we do when merging the feature branch, we do a squashing. But we'll talk about that in a second. Good morning. Missed the first half, but I'm excited to go back through these afterwards. Nice. Thank you, Josh, for coming. Good to have you here. So let's implement a couple more changes. Let's do, okay, I realized that I wanted to have 2 exclamation marks. Whoops, like that. So let's just come here and really just put whatever. Doesn't matter. Like edit another exclamation mark. And then maybe also we want to do a cons name equals to Josh. Thank you for coming, and say console log, like that. Thanks for coming. Josh, not name, like that. Okay. Let's not call name. Let's call this person name, like that. Because otherwise, here we get a complaint. Nice. And let's do that. Let's do edit something more. I don't care. Like that. So now what's happened is that in our feature branch, so in this branch that we've created, this feature, let's call these issue 1. And that one is issue 2. These branch that we've created contains a bunch of commits, right? It has ahead these commits. We can even check the history, and we can say, okay, fit, we've added some console log, and then we've added another exclamation mark, and then we've added something more. I don't care. We can even compare this, and if we compare this with staging, you can see exactly the differences. There is something, we're not behind staging, but we are ahead of staging with these changes in here, right? So now, when I'm ready with this, yeah, I'm pretty accurate to most dev commit messages. Yeah, you will see how it really doesn't matter the commit messages at all for the way that we work at Finsweet. But now that we are ready, we want to grab what we did here in issue 1, and we want to send that into the staging branch. Right, our code is ready to be tested. So there's gonna be a bunch of things that happen here. So let's try to break it down. So hopefully I don't miss anything. So first of all, what we want to do is we want to create a pull request. And a pull request is essentially just a way of sending that code. Well, not sending, but opening a request to send that code to another branch. So I'm going to say, hey, I've got a bunch of changes here in issue 1. I want to send those changes into the staging branch. Actually, you know what? Let's call this properly. Issue 1, create some code. Issue 1, create some code. So we don't get confused. Okay. So I'm going to create a pull request. And because I use GitHub Desktop, it's very simple for me. I just create a pull request here like that. And then in here, I'm going to add some proper description. I'm going to use a conventional commit system, okay, for the pull request. So I'm going to do fit. If you're curious about this, you can go ahead and read conventionalcommits.org. Essentially, here they explain exactly the naming convention when describing changes in our code base. So I'm going to say fit added our core logic, whatever. Okay, and here this is the main logic of our cool app, like that. So essentially, here what I would do is I would describe the changes that are included in here. So it includes blah 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 blah. So anybody who's reviewing this knows for sure, the changes that happen. Now, before creating this pull request, let's examine everything that is happening here. We've got a title that describes the pull request. We've got a description that describes the pull request. And down here, we can see exactly all the things that changed between before and after. So here, oh yeah, and I don't want to merge into main. Be careful about that. I want to merge into staging. So you can see here how we are wanting to send some code from issue 1 to the staging branch. So if we scroll down here, you will see how we can see the difference that there are 3 commits that we want to merge. There's 1 file that changed in total, and it's done by one contributor, which is me. And essentially here we can see the changes. In this case, it would be just this change, like it's an addition. But if there were multiple code changes, you would see the exact difference between the old version and the new version, like that. Okay. So we've got all the changes here, but also remember that we try to stay organized. So we want to implement a bunch of things here. First of all, everything that we do, we always peer review it. So nobody's merging any code into production, actually. So here, in this case, it would be fine because in staging, but still we try to always do peer reviewing. So here I would go ahead and tag Joe Krug, for example. Joe, probably you're not going to do this review, but I would ask Joe to be the one who reviews my code changes. Okay. And then here, I know that this is assigned to me because I'm the one who's been building this. So just for organization, I assign this to me. I could even add some labels if I wanted to. I could do that. Yes, this is an enhancement because I've been adding some code. If we had a project, we'll talk about projects later if we have some time. I would put that project. But really, all the most important part is that these pull request it's based on an issue that we've created. Remember that we created these 2 issues here. So we want to link that pull request to this issue. So we know, okay, this create some code issue. It's actually handled by this pull request. And the way that we do this in GitHub, it's by using closing keywords. So it's called linking a pull request to an issue using a keyword. That's very simple. All you have to do is just explain that a pull request closes a specific issue, and GitHub will recognize that. So here, I would say closes, and I'm going to say number 1, like that. So essentially, this is already linking both pull requests. So when I create this pull request, what is happening is that GitHub knows now that this pull request it's tied to the issue number 1. We're connecting things like that. Actually, you will not see it in here because it only happens automatically when you want to merge into production, into the main branch. So in this case, I would still have to link it manually. But when you want to deploy it directly to main, you will see how this connection happens just by writing these closes keyword in here. Just PR is actually a description since the commits are points in time, but the PR is when it's done. That makes a ton of logical sense. Yes, nice. So now if I refresh these issues here, the issues page, you'll see how this has a connection. Look at that. There's a linked pull request to this issue. So we know that this issue is being handled by this pull request. I can click on it and I can go ahead and see that this is the pull request that contains the changes, right? Let me close a bunch of stuff before I get more confused. So we've got our logic here. And if I didn't care about safety at all, I would be able to merge this. But actually, before merging this, there's a bunch of things that we at Finsweet want to ensure that happen. First thing is that let's try to describe this in here. We require a peer review always, okay? And right now you can see how yes, there's a pending review in here, but Joe, it was requested for review, but I'm not actually being forced to wait for that review. You can see how I could potentially come in here and merge this. So we want to avoid that, and what we do is to require this, we use what's called in GitHub branch rules. Branch rules. And essentially, it's a way that we can tell GitHub, hey, I want to add a bunch of rules to my branches. So I want to enforce everyone who's working in this project to follow those rules. Let's check it out. So let's go to our code base settings. And I want to check here branches like that. And here in branches, we can create what's called branch protection rules. So I'm going to come here, add branch rule set. And this rule set, it's going to be, let's start with main actually. And here I want to activate this, and then I want to target a bunch of branches. In this case, I want to target the main, actually, let's call this main protection like that. And in this case, I want to target both the default branch, and I want to include the staging branch like that. Can I do it by include a branch? No, like that. Okay, so the default branch, which is the main branch, and the staging branch will both be affected by this rule. And these rules in here, I can implement a bunch of stuff. Restrict creations, restrict updates, I can require linear history, merge queue, blah, 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 blah. There's a bunch of things that we can enforce people to do. In our case, what I want to do is I'm missing some stuff. Hold on, let me create this for a second. Yes, I want to do this. Actually, I'm missing something here. Hold on. Rules, rule sets. Require approvals. Yeah, that's done correctly. Restrict branch names, require status strict appeal, pass, require pull requests without merging. Oh yeah, here. This is the rule. Sorry, I forgot. So first of all, we don't allow people to merge directly into the branches. We require what we did, which is we created pull request. So instead of allowing people to go ahead and ship code directly to staging or ship code directly to main, we force people to create a different branch and then create a pull request to request to merge those changes. So we require a pull request without merging. We also require an approval from somebody. So we're saying, hey, you're not going to be able to merge that unless somebody else reviews your code and approves it. So in this case, we do 1%, but it could be up to 10%. Look at that. Then I think that require approval of the most recent reviewable push, require conversation resolution. Yes, we do also this, which means that if there's any conversations going on, first they have to be resolved before allowing people to merge that code. I think that we can do a practical case now. And request pull request review from Copilot. That's something that I might talk about in the future, but for now, let's not do that. And then we require the status checks to pass. I'm going to talk about this as well. Require branches to be up to date before merging, yes. And do not require status checks on creation. That's all fine. So cannot be empty. Oh, right, because we don't have the workflows yet. So let's remove this for a second. I'm going to show it later if I have time, and if not, maybe we can do next Friday. But now that we've got this main protection where we are require people to open a pull request beforehand, if we go back here, not the developer started, but in here, if we go back to our pull requests and we open this pull request again, now you will see how I'm no longer able to merge this. Look at this. This is now blocked in here. And the reason is because there are some rules now that are enforcing this. In this case, there is something that it's blocked because it's waiting for one approving review, like that. In this case, I would need somebody else to come in and review this for me. In this case, it's Joe, but that's not going to happen. So we've got into some trouble now. But I think that I'm going to show you something else that we do, and it's that let's go back to the rule sets, main protection. We've got a bypass list, and that's only when we've got some critical projects, like for example Wisp or something else that is being used actively in production. We always have a code owner in the code base who is allowed to bypass these rules in case that something urgent is happening. So imagine that for some reason Joe was sleeping, so he cannot review this, but I really need to push some code because there is something very wrong into production. We need to fix it. So in that case, we've got a bypass. In this case, I believe that it's the repository admins, I would say so. So let's save this. And now you will see how I am able to bypass this because I'm an admin on this repository. So I could potentially come in here and merge this before anybody else reviews this. Okay. Now, a couple more things that need to happen before we allow people to merge this code. One thing that we want this to happen is that all the checks must pass. Now, what the hell are checks, right? Because right now here, there's nothing, like nothing is being asked for. The checks are essentially automated linting, automated type checking, automated tests. Okay, so all the projects that we build at Finsweet, we've got 3 different checks. Maybe some other projects have more checks, but the base thing that we always do, it's automated linting, automated type checking, and automated tests. Linting means that we've got in this case, we use ESLint. We've got ESLint that automatically checks for common mistakes in the code bases, things that we know for sure that we don't want to happen. For example, using the bar keyword or adding some extra spaces where it should just be one line jump, or I don't know, like mutating a function argument, like some things that can be detected in the code, and we want to prevent them because it's not a good practice to do. So ESLint is checking for that. Then automatic type checking, what's doing is that it's checking for any issues in the TypeScript code, because in Finsweet, we work with TypeScript. And then last thing is that we've got some automated tests, which automatically run the application in the background and check for a bunch of things that we added. I think that I did a live stream about testing in the past. So if you're interested in automated tests, I recommend that you check it. Let's see, maybe Finsweet testing, automated testing. Yeah, there was a live stream 9 months ago. So if you're curious, you go ahead and check it out. Look at that. That's me. Nice. So we have all these 3 different checks we enforce those to happen before we're able to merge this. So, and actually, I can show you that if we go to the developer starter template, because I want you guys to see this. So I'm gonna come to the developer starter, and I'm gonna just open a new pull request. So let's open something random stream. Let's do some changes here. Let's do super quick name, and this name is gonna be stream, like that. And let's commit this, whatever, doesn't matter. And let's open a pull request super fast, create a pull request. And in this case, because this is a template, don't use this as an example. Because this is a template, we don't have staging, because this is not a real project that is being used. But usually, instead of merging into master, I would be merging into staging first. But into master, here I would say fit demo for live stream. Doesn't matter. We'll remove later just for demo purposes, like that. So you will see that now when I create this pull request, something happens because this repository is set up with the automated tests. You can see how this is preventing me from automatically merging because it needs one approving review. But also you will see how in a few seconds, yep, there are some checks that are starting. And these checks in here are the linting and type checking and the tests. We can even go in there and see the progress of these. So you can see how these has a bunch of jobs, a bunch of steps that are happening. And in here, this one passes, all good. We did a good job. And this one will eventually pass as well, like that. So let's wait. But you will see how essentially GitHub is running that in the background for us. And we cannot merge this code until we've got all the rules that are checked, which is somebody approved this, somebody rebuilt this code, and the automated checks pass. Come on, let's see if this happens. Right. Anyway, so this is the process that we follow at Finsweet. I could go into how we do the reviews, but essentially doing reviews at GitHub is as simple as just adding comments. So you add a bunch of comments. This is an example of a comment, and here you can start a review like that, and then this review can be just commenting, requesting for changes, approving, etc. In this case, because I created the pull request, I cannot approve it to myself, or I cannot request changes to myself. But this usually would be somebody else who is reviewing the changes in my pull request, and they might come in here and say, hey, I don't like this. Maybe it's better if you do X, right? And they would add those comments, and in here that would comment, they would request for these changes, like all the different lines where they mentioned some changes, they would request those changes. And that would mean that here in the result of the pull request, I would still not be able to merge it because I would say, hey, this person asked you for some changes. So you're not able to merge this until you fix those changes. So what I would do is I would then go ahead, work a bit more in my project, and then later I would go and ask for review again. Like, hey, I'm done with the changes. Can you check this again? So they would go in, they would check everything, and they would see, okay, yeah, now it's cool. And they would add a review comment, and they would come here and they would approve this. And the moment that this is approved, I would see all the green checks in here allowing me to merge. Like, hey, you are good. You can actually merge this. Does it make sense? Hopefully it does make sense. I'm seeing Sylvan excited for this. Super interested for more details on those checks. Next week, yeah, well, you can get pretty far with that live stream that I mentioned, Josh. So I recommend that you check that out. And if you're still curious about some things, let me know because we can do an additional live stream about these automated tests. Great. So let's just assume that everything here was correct. Joe added the review, all good. All the checks passed. My code is okay. My tests are okay. Everything is okay. And then I go ahead and I want to merge that code. Let's remember that we've got here our feature branch with some code, and we're trying to merge this into staging. We're trying to send this code into staging. Come on. I don't like this. Like that. Okay. So I'm not going to merge this. I'm not going to do a merge. What I'm going to do is I'm going to squash and merge. And that's the reason why at Finsweet we really don't care that much about commit messages. The reason is because here, this version contains a bunch of changes. So it contains like, well, actually we can check the commits. It contains all these commits, like added some console log, added another blah, 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 added something more, I don't care. And this could be like very long. It could be like 100 lines long. There could be a lot of changes, right? But in this case, because this is a specific feature branch where we know for sure that we're implementing this, issue one creates some code, we can just summarize all of these. So instead of sending all these changes, I can just squash this, I can blend this, and just create one single commit message that it's saying, hey, this contains the changes for the issue one where we created some code. So if I go back here, what I'm going to do is I'm not going to merge the pull request because otherwise it would send all those different commits directly to the branch. Instead, I'm going to squash and merge. And now you will see how we're merging into staging. So I'm going to squash and merge, and this contains the summary of everything. Confirm squash and merge. And now, if we go back to the staging branch, and I'm not going to close this because I want to talk about this in a second. But if we go to the staging branch here, you will see how now it has just one single commit additionally, that it's featuring added our core logic, and it has the summary of all the different changes that happened like that. And also it even links to the pull request that we opened. Very simple. Meaning that now this is like a package. This is a closed, a closed box that contains all the changes that we had been working on in here. So this little box now, whoop, was sent over here with a single commit message like that. Okay, nice. So one of the things that we also do is that we automatically delete the feature branches. And if you're interested, you can do that if you go to the repository settings and you go to the general settings and you look for a setting that it's called automatically delete head branches, like that. So now what happens is that whenever we merge a pull request, the branch that it's a feature branch, so this branch, it just, it's deleted automatically for cleaning purposes. So I don't have to manually come in and here and delete the branch. So now you will see how actually, let me go back to stream GitHub. This is now removed. We can go to staging. I don't care about this anymore, like that. And now staging contains some changes against master, right? So staging now contains, this is no longer existing. This is no longer existing. Staging contains a bunch of changes against main. Let's do another issue super quick. So the issue number 2 was fix the awful bug, right? So let's do it super quick. I'm just gonna need 3 more minutes and the live stream is gonna be over. So stay with me super quick because this will make sense in a second. So let's create another branch. Let's go to my code here from staging. Actually, I already have my branch. We created it before. And in here, one of the things that you will notice is that, whoops, now I lost what I did here. And the reason is, remember that there's a history, right? The staging branch now contains a bunch of changes that my issue 2 fix bug branch still doesn't have. You can see how staging was updated 3 minutes ago, but issue 2 fix bug was updated 31 minutes ago. One of the things that we can do is we can, I don't know if it will be shown here, but I can open my settings in GitHub Desktop, which is, maybe it's cut. Can I see that? I think that you can see it. And I'm going to merge into current branch. And I'm going to merge staging into my branch. So my history, it's updated. And you will see how it says this will merge one commit from staging into issue 2 branch. So I'm essentially just syncing my branch again with whatever happened in staging. So let's sync this like that. And now you will see how in my history, I've got these changed that was put into staging before. So now, nice, I've got my code here. So let's fix some bug, because actually there's a bug. I don't want to call Josh Jun. I want to call Josh like that. So we've got this bug fix. So let's call this fix Josh's name like that. And let's do the same process. I'm going to open a pull request. I'm going to request to merge into staging. And then I'm going to say that this closes number 2, which is the issue that we created to fix the bug. So let's connect this, fix the awful bug here. And also I'm going to ask to review to Joe, but I'm not going to do it, but you would do it usually. I would also fill all of this info, and then I would come in here and merge this. Let's just assume that all the checks had passed, okay? So let's merge this again, squash and merge into staging, all good. Nice. Look at that. The branch was automatically cleaned up because I added that rule. And now let's go to staging again. We can get rid of this local branch here. Doesn't matter. And now we've got staging here. We've got staging that contains a bunch of changes. It actually contains the both issues that we fixed. It contains the create some code issue and the fix some bug issue. And all of this is in staging here. And now we want to do the last pull request, where we are requesting to deploy things from staging into production. We are saying, okay, here in staging, we've been testing things out in staging.example.com. Everything looks good. We are happy with the results, etc., etc. So let's create a final pull request where we are going to do a production deploy. That's how we call this. And this production deploy essentially just contains all the changes that are going to just go straight to production. So let's do that. Staging, create a pull request. And the way that we do it at Finsweet is we just define this as a production deploy. And in here, we list everything that is included. So this means that this closes number 1, this closes number 2, and also I would also include the commits that's in there. And we've got some commits. We've got commit number 3, commit number 4, and actually I don't care about this one. So I would say commit number 3, it includes commit number 4, like that. I would ask another review. Remember that we always need somebody to review things when we try to merge into staging or master, etc. And now when I create this, you will see how GitHub knows, okay, you are trying to deploy into main, into production. So GitHub will automatically connect this to the respective issues. GitHub will automatically summarize things in here, saying, okay, it includes these commits in here. And now we can even compare the changes, like, okay, cool, we've got these changes in here, all good. Now I can come here and I'm not going to squash and merge, because now I don't want to mess the history in staging. I want the history in staging be exactly as main. Okay, so all these different commits, these commits are final. These commits are different feature implementations. So I'm not going to squash and merge from staging to production. I'm going to just merge things. Whoops. So I don't want to squash and merge. I just want to merge. Maybe somebody else would prefer rebasing, but that's it. I would need a whole stream to talk about this. So let's create a merge request into main. Let's merge this, confirm merge, and look what happens now. Oops, staging shouldn't be. I should have a branch protection rule for staging to not be deleted automatically, okay? Keep that in mind. But now if we go back to issues, look at that. Both issues are automatically closed now. And the reason why they were closed is because they were connected to this production deploy that we did. So this, you can see here how Alex Iglesias closed these as completed in number 5. And number 5, it's this production deploy that closes this. So we finally can close this issue automatically because it was shipped to production like that. If I go back and I check the other one, create some code, same thing. Down here, Alex Iglesias closed these as completed in number 5 because number 5 had this connection to these issues in here. Like that. Okay, great. So this is essentially how we work at Finsweet. That's it. I know that this was a lot of info, but hopefully, guys, you can follow along and maybe you can rewind a bit and check when something was not as clear as you would expect. If you have any questions, if there's something from this live stream that you really want to dig into more, send me a message, tag me in Twitter, or send me just a DM in Slack if you're in some group, share with me, whatever. And I can just do another live stream and talk about that. Okay, I'll be happy to do it. So I think that this is the end of today's Friday technical live stream. Hopefully you enjoyed this. Yash, I'm seeing your question here. I messaged you regarding that with copy component thing on Slack. When you get the time, please see that. I will check that. Thank you, Yash. Yeah. Nice, Sylvan. We'll have to rewatch. Sure. This was really helpful. Just get the days of the team-oriented stuff. Thank you for sharing. Nice. Thank you, guys. Appreciate the comments. See you, everyone, next Friday. Goodbye, all.